Let us see what is the relationship between K and Q in this video, and what is Q represent and how is it different from K. So Q is nothing but the reaction quotient. We are using reaction quotient if it is not obvious for us to see which direction the reaction will proceed, and if we have the initial concentrations are given and we don't have any equilibrium concentration, and then we can predict the direction of that equilibrium by calculating Q, which is exactly the same way how we calculated for equilibrium concentration and the value of K. We are going to do the same steps. Only difference is in the case of Q, we will have the initial concentration. After calculating the value of Q, we can compare that value with the K, equilibrium constant K. If K is equal Q, then the system is at equilibrium, no shift occurs. So if K is greater than Q, the system shifts to the right, that means product favored. And if K is less than Q, the system shifts to the left, that means it is reactant favored. Let's see some examples. The question is, for the synthesis of ammonia, the value of K is 6 times 10 to the power negative 2 at 500 degrees Celsius. In an experiment, 0.50 mole of nitrogen gas, 1.0 times 10 to the power negative 2 mole of hydrogen gas, and 1.0 times 10 to the power negative 4 mole of ammonia gas are mixed at 500 degrees Celsius in a 1.0 liter flask. In which direction will the system proceed to reach equilibrium? So we don't have the equilibrium concentration, so we have to use the initial concentration given to calculate the Q, and then we have to compare with the K value to find the direction of this equilibrium. So first what we have to do, we have to write the balanced chemical equation for the synthesis of ammonia. That means we are producing ammonia from nitrogen and hydrogen, and then we can balance it. After balancing, what we have to do, we have to find the concentration of each reactant and product given. So it is not given directly, but I have the moles and then the volume. So from that I can calculate the concentration, which is 0.5 molar. And for hydrogen, in the same way, we can calculate, it is given 1 times 10 to the power negative 2 divided by 1. I will have 10 to the power negative 2 molar. And in the same way for ammonia, 10 to the power negative 4 divided by 1, which is equal 10 to the power negative 4 molar. After getting the concentration, I can calculate Q exactly the same way we calculated for N K value. So the products divided by the reactants. So in the case of products, we have the concentration of ammonia as 10 to the power negative 4 to the power 2. And for nitrogen, we have 0.5. And we have for hydrogen, it is 10 to the power negative 2 to the power 3. So 10 to the power negative 8 divided by, because 4 times 2 is 8, and then 0.5 times 10 to the power negative 6. So that equal 1 over 0.5 is 2, and then 10 to the power negative 8 plus 6 will be negative 2. So that is our Q value. So we have the K value given as 6 times 10 to the power negative 2, which is greater than the Q value we calculated, which equal 2 times 10 to the power negative 2. So this is going to shift towards right. That means it is product favored. Or I can write right shift. Okay. Let's see few more examples. So in this case, again for the synthesis of ammonia, at 500 degrees Celsius, the equilibrium constant is 6 times 10 to the power negative 2. Predict the direction in which the system will shift to reach equilibrium in each of the following cases. So what we have here is initial concentration, that is represented by concentration and then put as 0, that shows initial concentration. So that is 1 times 10 to the power negative 3 molar, and nitrogen initial concentration 1 time 10 to the power negative 5 molar and hydrogen 2 times 10 to the power negative 3 molar. So first step is to write the balanced chemical equation. So nitrogen gas plus 3 hydrogen gas gives 2 NH3 gas. All are in gaseous phase. And then we will calculate Q because initial concentrations are given. We don't have the concentration at equilibrium. So we have to calculate Q. So concentration of ammonia to the power 2 divided by concentration of nitrogen and concentration of hydrogen to the power 3. So that equal, what we can do here is we can substitute the values. So that is 1 times 10 to the power negative 3 to the power 2 divided by nitrogen is 10 to the power negative 5 and I have hydrogen 2 times 10 to the power negative 3 to the power 3. So that equal 10 to the power negative 3 to the power 2 divided by 10 to the power negative 5 times 2 times 2 times 2 times, I'm just expanding. You can directly substitute and plug it in the calculator. So 10 to the power 3 times 2 is 6 and I'm taking the exponents to the numerator. So there is a negative 5 at the bottom, so it will be plus 5. There is a negative 9, so it will be plus 9. And then that divided by 2 times 2 times 2 is 8. So that equals, I'm getting 1 over 8 is 0.125 times 10 to the power 8. So that when I put that one in the scientific notation, it will be 1.25 times 10 to the power 7. So that will be our Q. So after getting the Q, compare that one with the K. So that means I have the K value given as 6 times 10 to the power negative 2 and I have the Q value calculated 1.25 times 10 to the power 7. Which one is bigger? Q is bigger. So it will shift to the left. So we can say left shift. Okay. The next question is concentration of ammonia is 2 times. So I will just write Q directly now. That is ammonia to the power 2, concentration of nitrogen and concentration of hydrogen to the power 3. And then we have ammonia concentration is 2 times 10 to the power negative 4 to the power 2 divided by 1.5 times 10 to the power negative 5 times 3.54 times 10 to the power negative 1 to the power 3. So that equal, I'm expanding 2 times 2 and 4 times 2 is 8. So to the power 8 divided by 1.5 times 10 to the power negative 5 and times when you expand that 3.5 times 10 to the power negative 1 to the power 3, we have to multiply 3.543 times and we have 10 to the power negative 3 because negative 1 times 3 is negative 3. So when you simplify, we will get 4 divided by, I'm just taking the numbers 3.54 and 3.54 times 3.54 and exponents together 10 to the power negative 8 divided by 10 to the power negative 5 times 10 to the power negative 3. Like I said, you can plug it in the calculator directly the way you want, but I like this way. So 4 divided by 66.54 you will get, and the exponents cancels because on the numerator negative 8 and in the denominator also negative 8, so it will cancel. So 4 divided by 66.54 will be 0.06. So that when I move the decimal, I will get 6 times 10 to the power negative 2, which is exactly the same value as given for K, which is 6.0 times 10 to the power negative 2. So we will not have any shift here. So I will just write no shift. And now we can try one more with the different numbers given. So what we can do, the same way we can calculate Q. You first do it and check your answer. Pause the video, okay? And then Q equal, ammonia concentration is 1 times 10 to the power negative 4 to the power 2 divided by concentration of nitrogen is 5, and we have concentration of hydrogen 10 to the power negative 2 to the power 3, that equal 4 times 2 is 8, so 10 to the power negative 8 divided by 5 times 10 to the power 3 times 2 is 6, negative 6, that equal negative 6. When you take it to the numerator, it will be plus 6, so negative 8 plus 6 will be 10 to the power negative 2 divided by 5, that equal 1 over 5 is 0.2, and 10 to the power negative 2, that equals 0.002, or you can just write 2 times 10 to the power negative 3. So we have the K value which equals 6.0 times 10 to the power negative 2, and now we calculated the Q value which equal 2 times 10 to the power negative 3. So which is bigger? K value is bigger, so it will shift to the right. This is a multiple choice question for you to try, and then pause the video and check your answer. In the question it is asking, at 450 degrees Celsius, 2 moles each of hydrogen iodine and hydrogen iodide are combined in a 1 liter rigid container. So we have the moles, we have the volume, so we can calculate the concentration of each, and then the value of Kc is given, the same temperature, right? 450 and 450, so, and that is given as 50. Which of the following will occur as the system moves towards equilibrium? So we can calculate, since we have the initial concentration, we can calculate Q, which equal hydrogen iodide to the power 2 divided by concentration of hydrogen, concentration of iodine. All are gaseous phase. So then I can just substitute each at 2 moles. So 2 square divided by 2 times 2, that means 4 divided by 4, that equal 1. So that means K value is given as 50 and Q value we got it as 1. So which is bigger? K is bigger, so the system will shift to the right. That means we will have more hydrogen iodide at equilibrium. So which answer is that? So more HI will form. So more H2 and I2 will form is wrong because the system is shifting towards right. The total pressure will decrease. The total pressure, it's 1 and 1 here, 2 moles here, 2 moles here, so we cannot go with that either. The pressure is not going to make a difference here. No net reaction will occur because the number of moles in the same boats. Okay, so that is not the right answer either because the equilibrium is shifting towards right as per the K value and the Q value.